Hello everyone, today I will show you the classic Trautz-Shorigin reaction and its incredibly beautiful variation using luminol, which gives a very unusual effect where the red glow eventually turns blue. So let's start with the classic demonstration. In the previous video I already showed this reaction using green tea as a reagent. Yes, green tea can glow. Watch that video if you haven't seen it, where I also explain the reaction mechanism. In this video, I will show the classic demonstration using gallic acid, which I specifically purchased for this purpose. First, I tried the procedure described in the article Glowing Teacup Demonstration, which is suggested for student demonstrations. Pause if you want to read it. I took water, added 0.2 grams of gallic acid, added 5 milliliters of formalin, then 5 grams of sodium carbonate, turned off the light, and added 10 milliliters of hydrogen peroxide. And I saw nothing, absolutely nothing. But I was filming with a super light sensitive camera, and unlike me, it saw a faint reddish glow after adding the peroxide. A very weak demonstration indeed. Naturally, this result did not satisfy me, so I took the procedure from another article. There, 2.5 grams of gallic acid are added to 50 milliliters of water, 5 grams of sodium carbonate were added, then I added 25 milliliters of formalin, turned off the light and added 5 milliliters of 35% hydrogen peroxide. This time the reddish glow of singlet oxygen was clearly visible. I had hoped it would glow brighter than my demonstration with 10 green tea bags in the previous video, but no, the intensity of the glow was the same. So if you want to see this reaction, there's no point in specially buying pyrogalol or gallic acid, because green tea gives practically the same effect. Now, a very spectacular two-color chemiluminescence using luminol. In fact, it's a combination of chemiluminescence and a clock reaction. Here are the reagents and quantities I used. Instead of sodium carbonate, I took potassium carbonate, and 0.8 grams of sodium hydroxide and 0.05 grams of luminol were also added to the reaction. I turned off the light and added 40 milliliters of 30% hydrogen peroxide. I sped up the recording because the reaction is a bit slow. At some point, the gallic acid in the solution is completely oxidized, and the luminol begins to glow. Also, the reaction starts to foam heavily and overflow the beaker, which is why it's usually done in a large beaker. That's all for today. Goodbye.